Let's get into a slightly more tricky situation with our concave mirror and still using this 1 over f is equal to 1 over u plus 1 over v formula. Let's now look at if we place an object inside the focal point. So in this case, let's put a little diagram over here. We've got our mirror here like this. We've got the principal axis there like that. And we've got our focal point here and our center curvature there. Okay. Now, what happens when we place an object inside the focal point, inside the focal length of the mirror? Well, the image that we get will end up, if you do your ray tracing, you'll find that the image will end up being magnified on this side and being virtual. So what way will a virtual image be handled in this equation? We'll see in a second. So let's look at the maths behind this. We'll take it that our focal length for our mirror here is given as 20 centimeters. And we'll say that the object is placed 15 centimeters from the mirror. So now we have to find V. Okay, we have to find V. Now, if we look, our focal length is 20 centimeters over here. Our object distance is only 15, so that's inside the focal length. So we're going to expect something slightly different with V in this case. So let's start to look at the solution to it. So 1 over, we always start with the formula, 1 over f is equal to 1 over u plus 1 over v. Now let's start plugging in values. 1 over 20 for f is equal to 1 over 15 for u plus 1 over v. And we're in the same situation as we were in a previous example, where we now need to try and get 1 over v on its own. So how do we get 1 over v on its own? Well, on this side, I just want 1 over v on its own, but 1 over 15 is added to it. So to get rid of that, I would have to subtract 1 over 15. So because this is an equation, I've got an equal sign here. I can't just do something to one side. I have to also do it to the other. So I'll subtract 1 over 15 from that side as well. So what I end up with then is this will cancel in some way. I'll have 1 over 15 minus 1 over 15. So what I'll end up with in the end is 1 over v on this side, because those will go away, and I'll end up with 1 over 20 minus 1 over 15 as my as the other side. Again, some students prefer if the unknown variable is on this side of the equal sign and the rest is on this side. So let's do that. We'll flip it over. 1 over v is equal to 1 over 20 minus 1 over 15. That might help some people. Okay. Now I'm trying to find v, but let's work out this again. Again, you can put this in with a calculator. You can just do 1 over 20 minus 1 over 15, and usually the calculator will handle fractions easily enough and give you a fraction answer. But I'm going to do this out. The common denominator here is going to be 60, because 20 will go evenly into 60 and 15 will also go evenly into 60. We've got a minus sign in between. So 20 goes into 60 3 times. So 3 by 1 is 3. 15 goes into 60 4 times, and 4 by 1 is 4. Yeah. So I got 1 over v is equal to that. Now, because these are both over 60, I can just subtract the numbers now, the numerators. So 1 over v is equal to what over 60? Well, it's 3 minus 4. So that's minus 1 over 60 is what I end up with. So similar to the previous examples that we had, I've got 1 over v is equal to minus 1 over 60. So how do I get what v is? Well, 1 over both sides would get me the answer to that. So v is equal to minus 60 centimeters. So now you can see that we've ended up with a negative value here. And we said from our ray tracing that we would expect that this would be virtual, a virtual image. It would be as if the rays of light came from an image over here, even though that, you couldn't get an image of this in a card, because in order to do that, you would have to somehow put your screen into the mirror or something, which is kind of nonsense. So we end up with v is equal to minus 60. Now this minus sign here, when we're talking about v for a concave mirror, and we'll see as well with some of the lenses, v being negative would indicate that this is a virtual